Hello and welcome to the AP Statistics solution to the 2016 number 6 problem. We have a scatter plot here, and a newspaper in Germany is reporting that the more semesters needed to complete an academic program at a university, the greater the starting salary. So more semesters means greater starting salary. That's what the newspaper is reporting. On the first year of a job, first year. The report was based on a study that used 24 people. We got 24 data points in here who had recently completed an academic program. Information was collected on the number of semesters each person in the sample needed to complete the program and the starting salary in thousands of euros for the first year of a job. This is all first year job. Okay, so we got data. It starts at 0 on the x-axis for number of semesters. It does not start at 0 on the y-axis, and you also have to keep in mind it's thousands of euros. So this is 30,000, 35,000 euros, right? Does the scatter plot support the newspaper report about the number of semesters and starting salary? Justify your answer. So they're trying to say that the more semesters you have, the greater the starting salary. And when you look at the scatter plot as a whole, and sometimes if it's hard to tell, I'd like to put like an oval around the data. If you look at the oval and you look at the overall pattern, as the number of semester hours increase, you always want to talk like that. So as the x-axis, or as the number of semester hours increases, or semesters increases, it's not hours, then the salaries are also increasing. As we go to the right, the salaries are increasing. So in general, yes, that seems to support the newspaper. I do notice right away that it seems to have groups. And I might mention that, but if you read further, you're going to find that they want you to talk about that later. But it's okay to mention it early. That's something you should be noticing, right? As your big three, the center and the shape of this. So it's a weak association, kind of moderate to weak. It is positive. I would say it's linear. There's no fanning or no unusual features, except for the unusual feature that you have three groups, or it seems to be three groups. All right, let's see what they had to say about that. They say the scatter plot supports the newspaper report about the number of semesters needed to complete an academic program and the starting salary because it shows a positive association. So because it goes up, then yes, that supports what the newspaper has to say. Okay, then they give us the regression statistics. So we have our table. I can see my y-intercept, 34, and my slope is 1.15 times semesters, right? We have that. We also have r squared there. Identify the slope of the least squares regression line. Well, that's 1.1594, and interpret the slope in context. So the way you want to word slope, so 1.15 or 1.16. So as the number of semester hours increases by 1, and you do want to word it that way. So for every 1 increase in the number of semesters, the salary will go up and 1.1594 thousands of euros. So, it's like 1,159 euros. All right, so just like that, as x goes up by 1, then the y goes up by how much? This much, right? So you got to put that in context. Let's see how they worded it. The slope is 1.1594 for each additional semester needed to complete in an academic program. The predicted starting salary increases by 1,159.4 euros, right? So just like we thought, let's look at the back. Here we go. Question, the next piece. All right, an independent researcher, so this is like somebody else, right, received the data from the newspaper and conducted a new analysis by separating the data into 3 groups. So they noticed the groups too, and they want to break them up to see what's going on. So the revised scatter plot has the different majors on it. We have business down here, we have physics in the middle, and then chemistry up here. Based on the people in the sample, describe the association between starting salary and number of semesters for the business majors. So the business are the circles. We have 3, 4, 5, 6, 7, 8. We have 8 of those. And if you describe that, it says describe, so I'm thinking big 3. So we have a negative linear trend. So it's going down. So that's negative. It does look pretty straight. So I'm going to say linear, negative, linear. And it looks pretty strong, at least moderate, but probably strong association. So negative, linear, strong association. There's no unusual features that I really see. Let's see what they have to say. For the business majors alone, there's a strong negative linear association between the number of semesters and starting salary, right? They just put a little more context on it. Business majors who need a greater number of semesters to complete an academic program tend to have lower starting salaries. So they're just talking about as the number goes up, the starting salary actually goes down. So it probably means that, I don't know, you can guess all you want, but they don't really want guessing. They just want the pattern. Okay, let's look at part D. Based on the people in the sample, compare the median starting salaries for the three majors. Well, I have 8 points, so I'm going to look for 4 down and 4 up because it's talking about starting salary. So that's going to be right in between there, which is about 38,000. This would be 4 down and 4 up, right in the middle of that somewhere. That's going to be, looks like about 49 or something. 1, 2, 3, 4 down and 4 up is right in here. That looks like about 56 or something. So I would say the starting salary, the first year starting salary for chemistry majors is the highest. The median starting salary for first year employees with the business major is the lowest at about 39, where the chemistry majors was about 56. And the physics majors are in the middle at about 49. All right, and that's it. I just want you to compare medians. So you just compare it, which is the biggest, which is the smallest, and by how much. So let's look at D. Business majors have the lowest median, starting at 38,000, followed by physics at 48, and then chemistry with the top. That's it. It's just where's the median and which one's big, which one's small. Okay, last question. Based on the analysis conducted by the independent researcher, how could the newspaper report be modified to give a better description of the relationship between the number of semesters and the starting salary? Well, in general, all three of them, as the number of semesters increases, for all three majors, the salary will decrease. So it's better to actually graduate with the lower amount of semesters in all three majors. Okay, so something like that where it's actually a negative trend, right? It's a negative trend for all three sets. Okay, let's see what they said. The newspaper report should be modified to account for major. Overall, majors that take longer to complete tend to have higher starting salaries, with chemistry the highest, physics the next, and business the lowest, right? So they're just saying that. Within a major, students who take a greater number of semesters tend to have lower starting salaries. So I guess the one thing I did miss is in the newspaper article, they should say something about chemistry majors make the most, physics are kind of in the middle, and business are the lower. We did talk about within each thing, the more semesters you take, the lower your salary is. Yeah. Okay, that's it for this problem. Thank you very much.